So today we're gonna look at NoSQL databases, what are NoSQL or not only SQL databases are, and one such example of those databases MongoDB, and we have a Python connector PyMongo for that. So we'll look into this today. So what are not only SQL databases? So these are non-tabular databases, which are designed to store data in a non-relational way. So which like it could be anything other than a tabular relational format. Yeah, these could be any document-based or key value-based databases. And the key features of these databases is that they are highly scalable. That if you want to add some new functionality to these databases, it's very easy to do it. And a lot of industries finds applications for using these databases in IoT and big data applications. And some of the tools which people use for these databases, depending on the use cases, let's say you have a graph connected data, let's say, for example, Twitter, where people follow each other. So there could be a graph-based databases at the back end of Twitter, or let's say, like another example, let's say Airbnb, where you have different listing for rooms or places to stay, where they have different attributes, let's say their daily price, what like price per night, or what amenities they have. So for that, probably MongoDB or a document-based database would make sense. So NoSQL databases in summary are of 4 types: key value, column family, graphs, and document. And today we will look at MongoDB as an example. And in the next tutorial, we will look at Cassandra. So moving on, uh, here's like what's the basic difference between SQL and NoSQL. So the most basic difference is that SQL databases are tabular databases where which are relational, which means that different tables in the same database are related to each other by keys. We could be primary keys or secondary keys. And in NoSQL databases, you don't have any relational databases. There is no one such structure in NoSQL databases. Could be anything like we discussed, key value, document, or graph. Uh, and for SQL, like we discussed in the previous 2 workshops, that there is a fixed schema for each table, but for NoSQL databases, there is no fixed schema. You can update or create new attributes to each entry based on the use case. And again, for queries, to update or change data or query or filter or anything related to SQL, we have SQL. And like similar, like we had DuckDB as an example, we saw in the last 2 workshop. But for NoSQL, there is no like one such standard for any query language. It's just based on database type. So for example, MongoDB has its own query language, which is different from the other graph-based NoSQL databases. And why is it useful to run NoSQL? Because it can handle vast amounts of data and scale out easily. Like if you want to add some new functionality, you can very easily do it with NoSQL compared to SQL databases. And like I said, there's no flexible schema design. So again, if you want to add some new functionality, it's easy to do with NoSQL compared to a SQL database. And another thing is that it's very high performance, where you have a lot of read heavy applications, like say for example, Airbnb, we are just trying to sort out things based on price or amenities or the location. So having a NoSQL or not only SQL database at the back end of Airbnb would make more sense than having a SQL database. And again, the 4th point is the versatility it provides in terms of what kind of what are the different types of data you can store. Like say, for example, you can document or key value or graphs. You can have multiple uh, models to store your data, and that's why learning NoSQL can be handy. Okay, so one such example of NoSQL database is MongoDB, which is a document-oriented NoSQL database, and it stores data in a JSON. So JSON is JavaScript object notation, which is basically a bunch of key value pairs connected into one big file. And the advantage is that you can index things in a JSON database, like provide index to each of the document, and indexation makes like querying things very fast for MongoDB. And the arrangement of data set is, so for SQL, we see that there is a database, then we have tables, and then tables have lots of rows and columns inside it. But since MongoDB is a NoSQL database, we have a very different order in which the data appears. So first we have the database, then we have a lot of collections. So collection is, uh, it's similar to what table is in SQL database. And then we have documents where we have one entry uh, for a data type, or for an example of the data. Okay. And PyMongo is a connector to connect with MongoDB databases. And in the tutorial, we'll see CRUD, which is create, read, update, and delete. And we'll see examples of all the four operations. And we'll see how we can query documents, and we can see how we can perform aggregations and to get some of the information from the database. Okay, so let's go to the Collab notebook. So once you have this Collab notebook, you can start running these cells from 1 to 4 and 5. And once it says that, okay, you're successfully connected to MongoDB, we can start. So people on Zoom, can you just give me a thumbs up whenever you are done with step number, cell number 5? Yeah, we are using the PyMongo connector, so our database is hosted on this MongoDB data cloud, where I have this sample data science workshop, which has around 9 databases, and there are 23 collections. We will have this Airbnb. Yep. Yeah, so I can repeat again. So we are looking at this sample database hosted on the MongoDB cloud. And it has 9 databases and 23 collections. So this is the database we will be looking at today. And it has like different types of collection sites. So our main focus would be on Airbnb, but if you want to explore more, what you can do is make a free account on MongoDB Atlas, and then there would be one option which says like you want to host the sample database on MongoDB Cloud. Once it's done with the hosting, you can start running the queries and see what you can extract from this data.
Is great.
Yeah. And for example, like in this database, we see only one collection, listing and reviews. But let's say if you go to some other collection, let's say sample restaurant, then you'll see like there are multiple collections inside. Chat. Okay, thanks, Mike, for sharing. We'll come back to the collab now. So right now I have an open email and password. I just made it for this workshop, but I do not recommend doing this, like putting your passwords in like a open notebook to everyone. So what you usually do is install this .env, which will create, so that you can create a .env file where you can store your passwords to connect to your cloud hosted database. But for now, we'll just get started with this. So once you have the successful connection to MongoDB here, yeah, and we would like to know that what are all the databases inside the cluster. So the command is that once you have this PyMongo client, you can have this function attached to it and call it list database name. So what it gives is like an iterator, which puts all the databases inside it. And once you run this for loop saying that, okay, just print all the databases inside. So you'll get, okay, these are all the databases inside present on the cluster. And To select one specific database, what you can do is pass the database name as a string into the client and say you want to connect to this DB. And yeah, once you have the database connected, this is very similar to how you do show tables inside SQL that you want to know that what tables are there into the database. So here similarly, you want to know what collections are there in your database. Once you run it, it will say, okay, there is one such collection available with the name listings and reviews, and we'll use this same collection for all our analysis today. Okay, next is before querying anything, you would like to know what kind of documents are present in your database. So once we have the first, so we'll try to get one example out of our collection. So the command is that once you have this DB set up, call the collection name and say find one. So the find one function would go and find one such example for your one document in the database. Yeah, this is similar as saying find one entry from your SQL table and print all the attributes. Okay, so right now we see that, okay, we printed the document, but it's just like one big chunk of text. It's not properly formatted. So what we'll do is this pretty print package is provided in Colab. So once we load it and use it to print our dictionary based document, and once we run it, you can see it just prints it nicely with all the key value structure starting to the end. Like we see the ID. So this is like the unique ID for this document, and how many. So since this is Airbnb data, we can see what attributes are located, like how many people this listing accommodates, what's the address, what are the amenities available, and what dates it is available. And here, if who's the host, and so on and so forth, like what's the neighborhood like, and all the attributes related to any such listing on Airbnb. And before starting to query our database, we would like to know that, okay, what are the different attributes available with one such document. So once you run the first key listings.keys here, it'll just give you the first level keys which are available for this document. And right now we would like to know that how many documents are there. So what you can do is same as like your database name, your collection name, and just call this function count documents. Don't pass anything, just an empty dictionary inside, and this say count everything inside that collection. Once unit, you will say, okay, there are around like 5,555 database documents inside. Okay, now comes the query part. Now I would like to know the number of listings with at least 5 bedrooms and 5 bathrooms. So that's the format of the MongoDB query that you would like to mention what you're looking for. Right now we are looking at bedrooms, and so GTE means greater than or equal to. So this pound sign GTE or dollar sign GTE 5, which means that you're looking at all the documents with uh, 5 or more bedrooms, and again similarly 5 or more bathrooms. And once you have this query in the dictionary format, pass it into the find function. Yeah. So this result is a MongoDB cursor. So cursor is that the result is not loaded into the memory. It will only provide the result once you access it. And once we run it, we'll say, okay, there are 23 documents matching our uh, criteria that we wanted to look at. All the listings available out of those 5,555 listings, how many of them have more than 5 bedrooms and 5 bathrooms? And once we run the query, we find now we are interested in finding, okay, what are those listings, and is our query correct? So what you do is, since results is an iterator, we can kind of iterate over all the results, printing the name of the listing and the attributes of bedrooms and bathrooms here. Yeah, once we run it, we'll get around the list of all the 23 entries with the name and how many bedrooms and bathrooms are there, and the URLs for each one of the entries. So these were just basic examples of how to query in database. Now we'll look at CRUD. So and so each of these expanded abbreviation means create, read, update, and delete. Where we would, so first one is create, that you would like to insert database. So for example, again, for Airbnb, let's say there is some new listing and you want to add that listing into the database. So you can use this insert one or insert many command to insert data into the database. Read would be similar to what we just did it, that you want to find some specific uh, specific documents which are according to the query. Like for example, we looked at all the rooms with 5 bedrooms and 5 bathrooms, and that's where we would use find. Okay, now we would like, now there is update. So update means, let's say you want to update something for the document. So for example, in Airbnb, let's say somebody is upgrading their listing and they are having new high-tech devices, let's say a smart TV or a smart kitchen available. So now how would you show that information available to the users? So that's where you can use update one or update many, that either you can update just one document or update many based on the condition. Let's say you want to update all the listings for the country Portugal, so you would use update many. And the other is remove documents. If you want to delete some documents based on some criteria, or delete many documents based on some criteria. So some for examples are like, let's say you want to find all the listings located in Portugal. So what you can do is that you can have this query where you will go to the address.country attribute and say that you're trying to find all those documents and listings where the country is designated as Portugal. So that's how you can find your query, pass it into the find function. Once you have this function returns your iterator, you can print out the address in the market that where this listing is located. So once we run it, you'll find like all those queries which are located in Portugal. So most of them are in the Porto here. Yeah. The next example of update, that to use update, we would like to have update all those listings in this country of Brazil and just set their attribute verified equal to true. So your criteria is defined as first that you would like to update all those listings in country Brazil, and what you want to update is you want to set this tag verified as true. So once you run it, can run this query and it will say, okay, PyMongo successfully updated the result. And how would you verify it? So what you can do is you can find any listing. So this would give you just one example of all the documents from the country Brazil. Once you run it, just print the name of that listing and the verified status, and it should say true because you have set the verified attribute as true here. Okay, deleting documents. uh, if you want to delete something from a specific host, like for example, somebody tries to leave or wants to leave from Airbnb and they don't want any of the listing present. So that's where you can delete these host listings that given the name of the person, go and delete all these listings. So the delete many command will delete the listings. And how would you verify that? You would go and search for the person's name and in the remaining list and see how many are there, how many are left. So let's go run. And we see 0 because there is no one in the database with the name John Doe. So we do not find anyone. That's like a generic name here. But now let's actually delete many entries for this host. So initially we started with 5,555. Now we run this. I made a mistake. Yeah. So once we run it, we want to delete everything by this name. Okay. And right now, once we deleted it, that we found that there was nothing. Uh, so we deleted the hosting for this person. And once we try to count a document with this attribute that find all these uh, listings with this name, and this should be here. Okay, and once we count again, yeah. Okay, there's one question in chat. When I look at the first listing, it has country Portugal pair, but if you look at the first listing dot keys, yeah, I think is it because country is in the address. So I think if you have to do, because right now, uh, once you do keys, it will just show you like the first level. And since because this is a nested document, right? So once you have this, and once you have, let's say, address here, in the address, there is the country Portugal. So you have to go one level down to access the country key here. I think that answers your question, Christopher. Yeah, that's a good question. I haven't tried it here, but there is some way to find nested keys. I think there is some like tree-based command that you have that tree command to just say what's the tree order of your keys, like what are the nested keys and what are the first level or second level key. Yeah, there should be. It's not in the tutorial right now, but I'll look at and send it to you. Yeah, we were here. So we deleted one listing by this name, uh, Anna, and then once we deleted that, we'll still count that how many documents we are left with. So initially we started with 5,555. Now we deleted one document by this host. So let's count again and we should see one document less. And again, another example is find all those listings which have this Wi-Fi and cable TV available here. And so again, the similar command is that we would like to find all those documents where your key should have these amenities. So this is saying that go and find all those documents where amenities matches with all these here. So once we run it, we can print like, okay, we have a listing and then what are the amenities available here. This is one way of like filtering documents based on the amenities. Next example is finding all those listings uh, with this price range of $900 to $1,000 per night. So again, we'll use that find function here, put the price in. So that's where you would like to filter the data on. And earlier we saw an example in the bedrooms and bathrooms example. We're using GTE, which means greater than equal to. Similarly, we can use LTE, which means less than equal to. So what is this saying? That find all those listings with their price per night between 900, greater than 900 and less than 1,000. Once we run it, it will just gives us all the listings with this price. So, so the result returns an iterator. And once we have this iterator, we can iterate over this, that the output of this find function or find query to get the listing, and we can extract the listing name and listing URL. Okay. Okay, let's look at the example of aggregate. So for example, you want to know that how many listings are available for each country. So what you would like to do is do a group function based on ID, where your ID should match your address.country, since we saw that country was at the second level of keys, which is hidden inside or like a one level down to this address key. So what you do is say you want to group your database based on the ID, where the ID matches with your country, and then you would like to sum it. So again, this returns an iterator, and once you run this, it will say, okay, this is here. So it will store that country into this ID key in the result, and then the count of the document here. So once we run it, we'll see, okay, it will just provide us with all the country names and the listings available for each country. Let's say in another example, you would like to know what's the average number of bedrooms and bathrooms available for country. Similarly, what we'll do as in the previous example, we'll store ID. So store the country and addresses into this ID key here for the result, and we'll say, look at this average bedrooms. Uh, so go to this bedrooms and bathrooms key, take an average and store this into this average bedrooms here. Once we run it, yeah, one thing to note that MongoDB has its own data types to store data. So for example, like generally we have integers, 32-bit or 64-bit integers and float. So MongoDB has its own probably like 128-bit based data type storage scheme. So what you can do is, uh, since right now we'll get this number as a very big number here. So if I remove this round function here, we'll get a very big float. So we can use this round function to just look it nicer here. Okay. Yeah, next is we would like to know that to understand which listings are more popular. So more popular listings probably have more reviews. So we are asking here that among all of your entries, get the get get the number of reviews for each entry, sum them up, and then sort them. So what it's doing, that it just goes into making this reviews count uh, attribute, and then calculating the number of reviews here. And next is sorts all the documents returned by the reviews here. It sorts them into a descending order. And now we are saying limit these results to 10. So this limit is very similar to what we have in SQL, that after the end of every query, we say limit and the specific number just to limit the results we obtain out of this query. So once we run it, again, it will return an iterator so that we can extract the name of this listing and how many review counts are there and what's the listing URL. So once we run it, we should see, okay, we have this uh, listing with like 533 reviews, which is the maximum, and then it starts decreasing. And we get 10 entries because we use this limit option here that limit our results to just 10. Okay, next is another example of looking at aggregate, which is average price by room type. And here I'll show you like how to use this decimal, that this average price is stored as a one big decimal 128-bit number of float inside MongoDB. So now we are trying to convert it to a Python data type here, and then just saying a round on it to 3 decimal places. So again, we start with, we are saying group all the documents, and the ID should be room type, and get the average of those prices and sort those prices based on the ascending order. So once we run it, we'll see that there are 3 room types: private room, entire apartment, or shared room. And it just calculates the average price by room type and uh, rounds it to 3 places to decimal, and then prints it. Okay, next is update. Like, for example, we want to look at adding a new amenity to a listing here. So for example, let's first get this one listing, and then we'll see how to do things. So once we run it, we'll see it returns this listing with this unique ID and what are the amenities available. So we see right now at the end, we just see it has a hair dryer, iron, laptop friendly workspace. But now we would like to add a smart TV here. So we'd like to say update this entry one. So that's why we are using this update one function, and we are saying, okay, go to this entry, find this entry by its unique ID here, and add to set means that we are trying to add smart TV into the amenities key. So the add to set, this dollar add to set is a function which is saying, okay, go to this amenities key and add smart TV into its value. Once we run this, it will say, okay, PyMongo has successfully updated the result. And if we have to verify this, we'll say, okay, our query is that find the entry with this ID. So we run it, it will have only one result inside. And once we run it, we should be able to see smart TV at the end. So using this, uh, we are able to insert one new amenity in the address in smart TV as a new amenity in the amenities key. Okay, next is update many, where you would like to have update uh, many documents or many listings inside the Airbnb database. So if you want to say you want to update all of the listings and you want to set this tag verified as true, this is very similar to what we did initially, where we set verified to all the entries in the country Brazil. So here we are saying instead of Brazil, just take all those entries and set this tag verified equal to true. And now it just sets this verified equal to true. Okay, now we'll look at the delete operations. And one thing is that any delete operation, just be careful that if you use it in an incorrect way, probably will mess up things. Okay, so here we would like to delete all those listings uh, which do not have any reviews. So how would you use it? So we'll use delete many and say reviews, where the review size of the reviews is 0. So once we run this, say we have deleted the result. And how would you verify it? So now you'll check that, let's say for the remaining documents or listings inside the Airbnb database, you aggregate all the listings based on the review count and sorted them in an ascending order. So if you have removed all those listings with 0 reviews, what you should get is all the listings starting with 1 review. And once you run it, it'll say, okay, it's in an ascending order, and now you have started with the 1 review. Okay. Yeah, and once you can see like, okay, so you have deleted all those listings with 0 reviews, how many are left? So what you can do is go here and see how many are left. And should say, okay, so so initially we had 5,555 entries. Then we deleted one using delete one option for one person. And now we have removed all those entries with review 0. So now we are left with 3,922 entries. And whatever change we have made till now is directly uh, getting updated into a database. So if you want to say like if this is correct, you can go look at your uh, cloud hosted database and it should show you some change at the back end once you look at it. So right now, initially we started with 555, and right now we can see here is that for Airbnb listings and reviews, it's showing me 3,922. So whatever changes we were making on this collab notebook were getting pushed to this database. Yep. Yeah, that's it for today. Please let me know if you have any questions.